EN 13501 Part 1 defines how construction products are classified by reaction to fire performance. This classification is not based on a single test. It is a sequenced system, and the pathway varies by product type. 3 product groups are defined. Construction products excluding floorings and linear pipe insulation. Flooring products. And linear pipe thermal insulation. Multiple test standards are used because products behave differently in fire. For this reason, EN 13501 Part 1 assigns different test routes. Most construction products rely on the single burning item test EN 13823. Flooring products instead use the radiant panel test EN ISO 9239-1. Each test isolates a distinct aspect of fire behavior. Can the product burn? How much energy can it release? How easily does it ignite? And how does fire develop across its surface? Together, the results obtained from the relevant tests are assessed in accordance with EN 13501 Part 1. These assessments establish both the main reaction to fire class and the additional classes for smoke production and flaming droplets, which will be discussed shortly. To clarify the main reaction to fire classes, the following interpretations apply. Class A1 designates non-combustible materials. Such products do not participate in fire growth. Common examples include stone, concrete, steel, and glass. Class A2 designates materials with an extremely limited contribution to fire. This category may include selected fiber cement products and gypsum boards containing minimal organic components. Class B describes products with very limited fire growth potential. While ignition may occur, fire development is strongly restricted. Examples may include fire-retardant treated wood and certain engineered composite materials. Class C represents a limited contribution to fire. Flame spread and heat release characteristics remain controlled within defined thresholds. Typical products may include various treated wood materials and thicker polymer-based panels incorporating fire-retardant additives. Class D reflects acceptable fire performance with a more noticeable contribution to fire. Examples may include untreated wood-based panels and certain plastic products. Class E indicates basic reaction to fire behavior. These products resist only small flame exposure for a short duration. Class F signifies that no reaction to fire performance has been determined. However, fire risk is not defined by ignition alone. EN 13501 Part 1 also classifies smoke production, the S classes, and flaming droplets or particles, the D classes. Smoke classes describe the rate and quantity of smoke generated during fire exposure. These are determined from the relevant parameter results obtained from EN 13823, commonly known as the single burning item test. S1 indicates strict smoke limits. S2 indicates moderate smoke limits. S3 indicates that no defined smoke limit has been satisfied. Flaming droplets or particles, the D classes, address the formation of burning droplets or particles and their potential to create secondary fire hazards. For construction products excluding floorings, classification is derived from EN 13823 and EN ISO 11925-2. 3 performance levels are defined. D0 indicates no flaming droplets or particles within 600 seconds. D1 indicates limited droplets. Flaming droplets or particles may occur, but none may persist longer than 10 seconds within 600 seconds. D2 indicates that droplet performance criteria have not been satisfied. This includes cases where burning droplets ignite the reference paper defined in EN ISO 11925-2. These classifications are expressed as suffixes to the main reaction to fire class. For example, class CS2D1. Real fire risk is dominated by smoke, loss of visibility, the release of toxic gases, and secondary ignition. A favorable reaction to fire classification combined with poor smoke or droplet behavior may still present serious danger. Smoke is one of the most critical hazards in fire, particularly in enclosed spaces. It originates from incomplete combustion, where insufficient oxygen prevents full fuel oxidation. Instead of producing only carbon dioxide and water, the fire generates a complex mixture of unburned particles, droplets, heat, and toxic gases, collectively visible as smoke. In real fire scenarios, smoke is the primary threat to life. Most fatalities occur due to smoke inhalation, toxic gas exposure, and oxygen depletion rather than direct flame contact. Smoke introduces multiple hazards at the same time. It is toxic. Fire gases such as carbon monoxide and hydrogen cyanide impair oxygen transport and disrupt cellular respiration, even at low concentrations. It reduces oxygen availability. Fire consumes oxygen while combustion products displace breathable air, creating rapid asphyxiation risks. It is thermally aggressive. Smoke efficiently transfers heat and irritants capable of causing severe airway injury. It severely limits visibility. Disorientation, and delayed evacuation significantly increase occupant risk. It can intensify fire behavior. Unburned pyrolysis products within smoke may ignite when conditions change, contributing to rapid fire development. Finally, beyond life safety, smoke also causes extensive property damage through contamination, corrosion, and persistent residues. In the modern built environment, where speed, density, and complexity continuously increase, fire events remain a persistent global risk. The danger is particularly severe in enclosed spaces, where smoke, heat, and toxic gases accumulate rapidly, and where vulnerable occupants may be present. Without appropriate precautions and proper material selection, such hazards are not theoretical, they are inevitable. Beyond the implementation of active and passive fire protection systems, the correct choice of materials, especially in high-risk areas, is a critical component of fire safety strategy. This is precisely why EN 13501 Part 1 is not structured as a single rating. It is a multi-layer fire behavior model designed to evaluate different aspects of product performance under fire exposure. Understanding this classification logic enables informed and responsible decisions. Because effective fire safety begins long before a fire occurs, at the stage of material selection.